Good evening and very welcome here to the Geological Society at Burlington House. My name is Elizabeth Donnelly and I am the Chief Executive Officer of the Women's Engineering Society. So we're slightly behind because, life. Thank you for bearing with us. These are our hashtags for today. So at Wes1919 is our account on Twitter, and also hashtag Caroline Haslett, hashtag Wes Awards 2022. And yes, I appreciate that we are now in 2023, but sadly rail strikes intervened, so we were unable to hold it in December. And for those of you who like these sort of things, we're having the team Christmas lunch tomorrow, which is a much different feeling from the equivalent time in December when it was 2 days before I was due to go on nearly 3 weeks leave for Christmas, and really looking forward to some festive celebration. And now it's, well, January, and we're really quite geared up for a new year. So this is one of my favourite events because we get to do two brilliant things. We hear from a fantastic leader of industry, Dr. Bola Olabisi, and the future of engineering with the winner of the Karen Burt Award, Memorial Award. Plus, we get to celebrate our Men as Allies and Amy Johnson Inspiration Award winners. And it's wonderful to promote women in engineering and these people who are doing that. Unfortunately, Dame Dawn Childs, who was awarded a damehood in the New Year's Honours List, is in Indonesia with work, so she does send her apologies, otherwise she would be doing a lot of the talking this evening. Also apologies from Dr. Catherine Critchley, who is the head judge for the Karen Burt Memorial Award. She really did want to be here, but unfortunately she had a family bereavement just before Christmas, and the funeral is today. So we're here at Burlington House, a neo-Palladian mansion constructed in the 17th and 18th centuries, owned by the Earls of Burlington, and was expanded in the mid-19th century once it was purchased by the British government. Today, the Royal Academy and 5 learned societies, including the Geological Society, have occupied the house since 1874. However, in 2019, the government informed the occupants that they will have to pay commercial rents by 2022. This has been extended a couple of years to the pandemic. And this is a move that will actually bankrupt the learned societies. So despite a vigorous campaign begun in 2020, the government has remained immovable, and the learned societies are considering their options, which will potentially be a smaller footprint here. But this is just to say we shouldn't take these wonderful places for granted, because this may be one of the lifetimes that we get to gather in such a beautiful setting. Having said that, this is the Janet Watson Lecture Theatre. She was the first woman to be president of the Royal Geological Society. There is a sketch behind you, and I believe there's a full portrait in the library. And I think it's very wonderful that here we are celebrating women engineers, and that this theatre is named for a woman. I'm now very delighted to welcome, to hand over to Huda Assad, who's from our sponsors, Accenture. This is the first time we've had a sponsor for this lecture, but we work really closely with Accenture, and they're delighted to be supporting us today. Thank you, Huda.
Thank you, Elizabeth. Hello and welcome. I'm absolutely delighted to introduce the Women in Engineering Society's annual Caroline Haslett Lecture. So we're all here because we have an unwavering commitment to champion equality, equity, and breaking down barriers. Though the world has come a long way since Caroline Haslett's original ambition, which was to use the innovative power of electricity to free women from the drudgery of household chores, I'm not sure that's fully achieved yet, there is still much to be done. So what about innovation in 2023? Well, innovation equals survival. Sounds very serious, but it really is. It's well documented that in this age of widespread disruption, companies must innovate continuously, creating new markets, experiences, products, services, content, and/or processes. Accenture research has found that a culture of equality and equity is a powerful multiplier of innovation. If organizations want to thrive and survive, they have to get to equal. Employees in the most equal cultures report having fewer barriers to innovating at work and are less afraid to fail. I mean, sounds obvious, doesn't it? This doesn't mean just hitting the numbers. We need to be building a culture of equality and equity, a culture of equality which offers an empowering environment, bold leadership, and comprehensive action, which enables people from all gender identities and backgrounds to succeed. That's because in a culture of equality, people are truly valued for their differences and are free to be who they are. They're not just there to tick a box. And I would tell you, I probably experienced that several times in my early career. They're here, they're empowered to contribute. And that's so important. So what actions can we take to realize a culture of equality? At Accenture, we've set bold targets to accelerate gender equality. We're committed to being a place where women want to work because it's a place where everyone can thrive. We are working to achieve a totally gender balanced workforce by 2025. Today, women make up 50% of our board directors and 47% of our global workforce. For me, that's a very novel experience, having grown up in an engineering background, a civil engineering background. We promote women at all stages of their career and invest in targeted support, flexible working arrangements, and comprehensive training programs to help women thrive. This is where the equity thing comes in. It's not just about equality. We also promote and engage in open, honest, and meaningful conversations to further advance equality and equity for all. A final thought before I hand over back to Elizabeth. For Caroline, innovation was a means to achieving a culture of equality. Today, a culture of equality can only be driven if we have innovation. Thank you. Hand over back to you.
Thank you, Huda. This lecture is named for Caroline Haslett, and we were fortunate enough to receive recently receive an early photograph of Dame Caroline Haslett, which you can see here that we've blown up. Apologies for the green stripes. This is because the original has a library card on the back, and we don't want to remove it because it's going to go into our archive, and all that information is part of the information that helps inform the items that we have. And it's my absolute pleasure to introduce Anne Locker from the Institution of Engineering and Technology, who is the Library and Archives Manager, who really knows our archive very well, and who's also responsible for the archive of the Electrical Association for Women, of which Dame Caroline Haslett was the director. And she's going to give us a history of Caroline herself. Thank you.
Good evening. My name's Anne Locker, and I'm the Library and Archives Manager at the Institution of Engineering and Technology. And we're lucky enough, as Elizabeth said, to hold the archives of Women's Engineering Society, but also the archives of the Electrical Association for Women and the personal archive of Dame Caroline Haslett. So today I'm going to talk to you about Caroline Haslett. She was the first secretary of the Women's Engineering Society, a post we'd now call CEO. She was the director of the Electrical Association for Women, and she was the first woman to serve on the board of a British Electricity Authority. I'm going to look at her background and some highlights from her career, focusing on her interwar work with the Women's Engineering Society and the Electrical Association for Women. I'm going to look at how her work experience and her personal qualities uniquely qualified her to be the only woman appointed to the Institution of Electrical Engineers Electrical Installations Committee, which in 1944 published recommendations that gave us, among other things, the 3-pin plug and the ring circuit. And finally, I'm going to summarise some of her policy work, which we don't tend to talk about so much of Caroline's work, in the 1950s, where she worked with the UK government, the International Federation of Business and Professional Women, and the United Nations. Caroline had an exceptionally successful career in a world that was not a natural fit for a professional woman in the early and mid-20th century. I want to look at what she achieved, but more importantly, how she succeeded in being one of the key figures in the electricity industry at this time. Now, and that's her launching the British Electricity Authority colliership, which was called Dame Caroline Haslett. Now, I want to start with a photograph. Here is Caroline at the peak of her career in 1954, and this is a dinner of the British Electricity Authority in honour of Sir John Hacking. Now, if you look at the photographs from this period, this is pretty much what they look like. all men completely in suits, and Caroline. I mean, she's often the only, I mean, she's generally the only woman in the room, literally the only woman in the room. The only unusual thing about this photograph is she isn't wearing a hat. She normally has a kind of very long series of kind of fetching hats that she wears at these occasions, but this evening she isn't. Now, Caroline had a busy and varied career in the engineering world from the First World War until the mid-1950s, and she was involved with a dizzying number of organisations, committees, working parties and campaign groups. And with the exception of those groups founded by and for women, she was often the only woman in the room. And I want to pause on how extraordinary this was. Women were working as professional engineers at the time. Of course, the Women's Engineering Society had been founded in 1919. And women were able to join professional engineering organisations. The Institution of Electrical Engineers, a forerunner to my own organisation, the IET, welcomed its first woman member in 1899. But women were still disadvantaged when it came to employment in industry. The Amalgamated Engineering Union did not admit women until 1943. The numbers of women were creeping up, but it was still rare to find women in managerial positions, beyond those who worked in supervisory roles in wartime when employment restrictions were relaxed. And here's an image from just after the Second World War, and that's the young Princess Elizabeth being shown by Caroline Haslett along with Queen Mary on electrical industry visits. So how did a woman who came from a modest background and with a basic engineering training reach a position of being, in the eyes of government, the best representative for women's interests in electrical engineering in the UK? And how did she also find the time and the energy to campaign for equal pay and access to professional work on the national and international scale? Now, Caroline hasn't had many jobs. You might say that she wore many hats, and she achieved many things, but would we describe her, or would she have described herself as a professional engineer? Now, before those who know a bit more about her life and career object, what I mean is that with the exception of her early training, she didn't hold a professional post as an engineer. Her contributions to engineering were not necessarily on the technical side. What she did was make engineering happen. If I were to be slightly fanciful, I'd say that she was a nexus of engineering. She was a connection between multiple networks and a focal point around which those networks and the people within them could operate. Without her work, the Women's Engineering Society would not have flourished, the advent of electricity in the home would have been curtailed, and the campaign for women to enter the professions and to be paid equal wages for equal work would have been severely diminished. Now, let's begin with a brief biography. Caroline was born in Sussex in 1895. She was not particularly academic, but her family encouraged her to train for a career. She decided on a secretarial course in London, and in 1914 she got a job as a junior clerk at the Cochrane Boiler Company. Now, during the First World War, like many of her peers, Caroline took the opportunity to extend her work experience and training. As I said earlier, laws and conventions around employing women had been relaxed due to the needs of wartime. And by 1918, Caroline was not only running the London office, she was sent to the company's works in Scotland to be trained on the manufacture of boilers and to undertake a basic apprenticeship. She loved the work and had found her vocation. And this is a quotation from her biography, The Doors of Opportunity. She said, "As soon as I got into the works, I knew this was my world." At the end of the war, one of Caroline's colleagues showed her an advert from the journal Engineering, which read, "Required lady with some experience in engineering works as an organising secretary for a women's engineering society." After an interview with the redoubtable Lady Parsons, and who was mother of the first Women's Engineering Society president, Rachel Parsons, Caroline joined the staff in 1919 at a salary of £200 a year. Her employers were less convinced, and there's a copy of this letter in the library if you want to have a look at it afterwards. They congratulated her on her new post, but there's a cautionary tale. It said, "We've read the leaflets you enclosed with considerable interest, but I must tell you that Mrs. Davis was rather shocked at the bad economic sentiments contained in the last clauses of the second leaflet, and hopes that when you are responsible for these publications, you will see to the arguments being sound." Shorthand for it was a bit radical and I didn't really approve. Women's Engineering Society was, of course, a fairly small organisation at this time. It began with only 20 members and had reached 111 by 1930, and this is the WES Conference from 1923. Caroline Haslett was a fortunate choice. She was the ideal person to make sure that the young society was organised and effective. She set up the Woman Engineer Journal, this is still going today, and steered the organisation through its early years. By 1925, she was helping to organise an international conference for women in science and industry, chaired by Lady Astor. That's Lady standing up. At the same time, she had to manage the dramatic resignation of WES's founder, Lady Parsons, who clashed with Caroline over the conference programme. The previous year, 1924, saw the foundation of the Electrical Association for Women, set up to promote women's use of electricity in the home. It had been proposed by Mabel Matthews, but not everybody in WES approved, notably Lady Parsons. Caroline was one of its founder members, and she was the first director. The EAW's slogan was Emancipation from Drudgery, and its aim was to encourage women to use electricity in the home to lighten the domestic load. This was great news for the electricity supply industry because they wanted women to take up domestic electricity supply and, of course, to buy and use the new electrical appliances like cookers, washing machines, irons and heaters. This tea towel, they produced a range of tea towels as well as dusters for educational purposes, showed some of the delights on offer and how economical they could be for housewives. So it shows how many units of electricity that you'd use to operate different appliances. So the focus was on electrical economy and the need for smart choices, something that we're still obviously talking about today. So here's Caroline Haslett in her office of the Electrical Association for Women. She's proved herself to be an able administrator and a voice for women's interests in the electricity industry. She's also demonstrated real talent for managing difficult people and for being a calm but focused voice in the face of conflicting opinions and ideas. Now, it'd be helpful just to summarise what some of the things that are going on around women engineering in this interval period. When it comes to the campaigns, we have two main threads. First, we have Lady Parsons and others whose main focus was on the training and employment of women engineers. They were not as concerned about how engineering affected women in general, for example, the advent of domestic electricity. They were all about the very important campaign for equal access to employment and rights for women. The solutions they proposed were direct confrontation. For example, and this is an example of a letter sent to Rachel Parsons in 1919, confronting the unions over their refusal to admit women. This is rather nicely addressed to dear sir and brother, but that's really as polite as it gets. It basically tells her in no uncertain terms that they're not going to look at admitting women into the union, and it's a bit pointless to have a meeting to talk about it. Secondly, we have those who are more concerned with the wider impact of engineering in society and how it could be used to improve all women's lives. In the context of Caroline Haslett's work, this is primarily on the electrical engineering side. First, the foundation of the EAW and engineers like Margaret Partridge, Caroline's friend, who set up a small domestic electricity business in the Southwest in 1921. Theirs was a slightly more collaborative approach. They worked with industry and existing professional institutions to speak up for women as consumers, as well as professionals. In particular, Caroline recognised the need to work with a male-dominated electricity supply industry and electrical appliance manufacturers. The Electrical Development Association, for example, which was the industry body in charge of selling electricity in the UK, gave large donations to the EAW. The EAW knew how important women were for the growth of domestic electricity supply. At this point, women are increasingly the ones making decisions on new purchases. And of course, they would usually be the people operating the new machines. As a campaigning consumer group supported by industry, the EAW was a strong voice, and here are some of their publications. And when I talk about these two approaches, although there were some tensions, there were also opportunities to work together, and Caroline herself did an excellent job of bridging the two groups. She continued to work for Women's Engineering Society, becoming president in 1940, as well as working with the Electrical Association for Women. So this meant that by the early 1930s, Caroline had two strong networks, WES and the EAW, and she was acting as a bridge between them. So how did she use these networks to try and make a difference? In 1928, the EAW spearheaded a campaign on electrical outlets in the home. It proposed that for new homes, the minimum number of electrical sockets should be 13, with 3 in the kitchen, but the campaign was not a success. The EAW did not yet have a political capital or the professional clout to force the industry to listen. All they could do was to promote and advise. But Caroline didn't give up. On the contrary, she strengthened her position by adding another network, one that covered the political arena. In 1930, the president of the US Federation for Business and Professional Women's Clubs, Lena Madison Phillips, visited Europe with the aim of encouraging international cooperation between women's clubs and organisations. She founded the International Federation of Business and Professional Women, and in 1932, the British Federation was formed. Its first president was Lady Astor, who you met back in 1925, and its first chair was Caroline Haslett. As with the early years of the Women's Engineering Society, Caroline had another clash with a strong personality, Beatrice Golden Holmes. The British Federation had decided to remove the word clubs from its title and asked that any groups joining should be made mostly professional working women. This ruled out some organisations, and Beatrice, who had met Lena Madison Phillips in 1936, set up a separate network, the UK Federation of Business and Professional Women's Clubs. It's very confusing. There are lots of names that are pretty much the same. So we had two federations, didn't agree with each other, and an international federation that wanted a clear line of communication. The solution, supported by Caroline and typical of her instinct to bring people together, was a bridge committee. This committee would report to the International Federation and act as a link between the two UK bodies. Caroline, of course, sat on the bridge committee, and it worked at least until her death in 1957, when a lack of funding led to the dissolution of the British Federation. Caroline also continued to build the EAW, which had over 80 branches by the 1930s, and she became even closer to Lady Astor and other prominent women MPs. In 1939, Lady Astor chaired an informal meeting of women's organisations, including the Red Cross, the Royal College of Nursing, and the Sooptimists. The aim of the meeting was to discuss the needs of women in the forthcoming war. This informal event would lead to the formation of a Woman Power Committee in 1941, which aimed to advise the government on the training and employment of women in wartime, and Caroline was, of course, a member of the committee. When Ernest Bevin was appointed Minister of Labour in 1940, he was pressured to appoint a senior female civil servant who would advise on the wartime employment of women, but he didn't want to do that. Instead, he set up the Women's Consultative Committee, or WCC, and he had appointed Caroline Haslett as his advisor. She threw herself into the role and was soon having brisk fights with the civil service about how far she was allowed to communicate independently with the press. Having won that fight, she gave a series of interviews and talks on women's work in wartime, including this article, which is from the Queen magazine, on how the country needs competent women. The role put her in an excellent position to advise the government on matters relating to women after the war. As an IEE member, the EAW director, and with her experience of working in government and policy, she was an obvious choice for the IEE's Electrical Installations Committee, which was formed in 1942 and published its recommendations in 1944. So Caroline had moved from the head of a lobby group that had not succeeded in changing industry policy to the official body advising industry on the same topic. This time, she would be heard. The EAW of 1928 would have been absolutely delighted with the committee's recommendations. These included an adequate number of sockets for electrical appliances in the home, planning for new appliances that were not yet standard, and safety was stressed, especially for recommendation of a new plug and socket that would become the standard UK 3-pin plug. Notably, the section on electric cookers, and this is an illustration from the final report showing the layout in a fitted kitchen of electric oven and utensil cupboards. The report actually states that we've been guided by the views expressed by the women of the country through their various organisations. And we should note that the only women's organisation with official representation on the committee was the EAW through Caroline. After the war, the Women's Consultative Committee continued to advise the government on the employment of women. Now Caroline's role with the British and International Federations of Business and Professional Women came into its own. She's been credited with unifying and politicising a federation, enabling it to speak with a single voice on issues important to women. And the International Federation developed close links with the newly created United Nations, especially UNESCO. By 1951, the British Federation for Business and Professional Women represented 90,000 women in the UK, and Caroline had been elected president of the International Federation. She even brought the administration of the Federation into her existing networks, and the office was run from the EAW's HQ in London. And this is exactly how she developed the EAW back in the 1920s, running the office from the WES headquarters. Her presidential address for the Federation focused on equal pay and vocational training for young women. She also preached the importance of cooperation, saying we should begin to examine and analyse the ways in which men and women can become real partners. And finally, I want to take a very quick look at some of the post-war campaigns she had a hand in: equal pay, part-time work and vocational training. In 1945, the WCC submitted a report to the government on equal pay, stating that women, rather radically, should be paid the rate for the job. They fought against the assumption that women would be provided for by men, and against the idea that access to professional careers was more important than equity for women in work. So the early campaign had been to allow women to be engineers in the first place. This campaign was to ensure that once they became working engineers, they were paid the same as men. And they said this was especially true for professional women who had exactly the same costs and fees to pay as their male counterparts. They also looked at part-time working, reporting on the employment of married women and observing that part-time work was seen as more attractive for women, but perhaps less so to employers. Again, a conversation we're having at the moment around hybrid working and flexibility. And in 1953, the International Labour Organization held an inquiry on access to apprenticeships for women and girls. And Caroline asked the president of the Women's Engineering Society at the time, Sheila Leather, to submit a report on women in the engineering industry. And Sheila reported that more girls were going into apprenticeships due to the skills shortage. Again, a topic of discussion for today. So in 1955, Caroline's health started to decline, and she gradually distanced herself from her public roles until her death in 1957. So this 1954 photograph shows her at her strongest. She has fought for her right to sit at the table, and she's made a real difference to the lives of many women. She's done all this not as a specialist or necessarily as a professional engineer, but as an administrator, a bureaucrat and a civil servant. She has expertly built networks more or less from scratch, and she's bridged these networks so those within them could see what they had in common, not their differences. And that is how she got things done. Thank you. And that is contact details if anybody's got any questions. That incidentally is the Women's Engineering Society 20th birthday lunch, 21st birthday luncheon, back in the 1940s. So, thank you very much.
Thank you. That picture of Caroline on her own with all those men, occasionally in my past I have been that woman. And it's a shame that it's still so many years later and it's still the case, but it's so delightful to see so many women today. And as the Caroline's successor, one of the joys of my life is that I get to meet so many brilliant women in engineering, so that I don't think there's a problem in engineering, because all I do is meet women engineers. So now to move on to the main Caroline Haslett lecture itself, I'm delighted to introduce Dr. Bola Olabisi, who is the Chief Executive Officer and founder of the Global Women Inventors and Innovators Network, known as Global WIN, a fellow of the Royal Society of Arts, and was recently appointed Director of Intellectual Property Awareness Network. She also did us the very, very great honour of being the head judge for the top 50 women in engineering, inventors and innovators in 2022. Dr. Bola Olabisi.
Thank you very much. Good evening, ladies and gentlemen. Thank you very much. That was a really enlightening presentation. Thank you so much. That's going to be hard to follow, actually. But yes, I thought I would talk to you about celebration, inclusivity, and ingenious solutions. So I have to put up my hands. First of all, I'm not an engineer, but I guess I'm speaking to a lot of engineers here. So I wonder whether I should be talking about engineering. But one of the things I thought I'd do is, first of all, give you an idea about who I am. Born in Coventry, British, of Nigerian parents. I had a father, well, he's still alive. I have a father with 13 children. So I've got 12 siblings. And being a civil engineer, he made it clear to each and every one of us that you have two professions in this house. If you're an African, you're either, medical doctor, engineer, lawyer. You didn't have very much to choose from. And I think we all kind of disappointed him because none of us went down that route. But I have to say that in 1998, I just discovered this real passion for inventions and innovations. And it actually pleased my father because he said, well, you didn't quite make what I wanted you to do, but inventions, yes, why not? And at that time, I was really frustrated as I found only a very low percentage were actually succeeding with little support at that time in 1998. In fact, I remember that quite a number of people were asking me, why would you bother? Inventors are men, white beards, usually in the shed somewhere. You know, we can't identify, we can't relate to this new passion of yours. And this isn't that diverse anyway. And how many women inventors do you know? And all of those sort of questions kept coming up. But all the same, I decided that we should do something. That within no time, I was on BBC Women's Hour talking about this, about the shortage of women inventors, and asking if there were any women inventors out there, and if there were, could they please contact us so that we could try and come together. It was only meant to be something really small, nothing too big. I wasn't ambitious about it. Maybe perhaps a few coffee mornings and stuff. But I found out when women started contacting me that there's a whole huge issue here that we need to really look at. And before I continue, I just wondered, in the room, are there any inventors here? Good. Nice to meet you. Well done. Any others? The hands are slightly not sure. I know, but I usually ask this question and the hands just don't fly up in the way that I was hoping that, because when I would ask the question in 1998, we would see this, and it's still the same. But I just happen to be someone that really appreciates and celebrates concepts, structures, equipments that are created to provide a better quality of life. My background is really in community development. And when you work within the community, you see a lot of people who are at a disadvantage. And so when you see people who are out there creating opportunities, inventions that create a better quality of life, you start to understand why I have the passion that I have. Today, I am pleased to see more tools and platforms for women in STEM. Kudos to Women's Engineering Society and others for their relentless work. So well done. Why inventors? So why take on inventors, the issues, the need to celebrate? Why do we need to celebrate inventors? The need for inclusivity, the challenges, the signpost platform that we created, the need to pass it forward, the need to collaborate and invest in partnership, need for global outreach and acknowledgement. There's quite a lot there for inventors that we're trying to do. I'm not going to go through all of this, but I will say that it's obvious. I don't think anybody would argue today that women invent. I don't think people would argue that we're of our capabilities What do DNA replication, bioplastics, reinforced concrete, video streaming all have in common? Women are leading inventors in these areas. And there's so much more. There are people coming up with books, publications, talking about women historically and even now today. So why? Why are we still talking about women inventors in this way? So why celebrate inventors? The reasons to celebrate are quite obvious, as I mentioned, apart from the fact that inventions rock. Engineers have similar objectives as inventors. For improvement of quality of life for people and the society, economic growth, which I'm sure you all probably know about, new capabilities, opening up new possibilities and opportunities, improved efficiency. So I think engineers can relate to inventors in some ways, making life easier, safer, healthier, more convenient. So there shouldn't be a problem, really. We all know this. But there is the downside, and it is an uphill struggle for inventors. And this is one of the reasons for why I really do take the opportunity when I have it to really bring it down to what the challenges are. And I'll put 5 here that I think we need to understand about what some inventors go through. Misconception. There's usually a lack of understanding sometimes, because sometimes it's in the mind of the inventor. They know exactly what they want to achieve, but sometimes we find it extremely difficult to understand where they're coming from. My experience is that some inventors are really good at what they're doing, but they're not great speakers. They're not really very good at promoting. I mean, what we saw on Dragon's Den, I mean, those are really great inventors, some of them. But the majority of the ones that I noticed are not really necessarily the people's person that's going to come out and promote quite a number of things. High risk of failure. At the time when we started, we were told only 3%, 5% of inventors will actually succeed. So why bother? Financial losses, negative consequences, the cost and affordability, ethical concerns, what materials are they going to use, when is it going to be complete? There were so many issues that were being thrown at us. And I remember speaking to a bank at the time to supporters, and they were like, but you know, inventors, I mean, if you were talking about innovators, business people, engineers, but inventors, I don't think so. Now, come back when you come back. When you come back to us and talk about all these others, but certainly not inventors. So I quickly discovered that to actually say you're an inventor may not necessarily be a good thing for some people and in some organizations, because it's just not a cool word to use, because perhaps of the word disruption. Some inventors do disrupt. They bring in changes that disrupt, that creates resistance from some existing organizations. All of these things matter. And for those reasons, it's usually very difficult to find those organizations that would actually want to support an organization that's looking at inventors. So we quickly knew that we had to add innovators to our name. So it became Global Women Inventors and Innovators, because we couldn't really just, focus on inventors. So why women inventors and the untapped opportunities? So I thought I'd give some figures. I don't really like using figures, and all, especially at this time of the evening, but there are some people, if they don't see the facts and figures, they're not going to believe that we have an issue here. So here we are, some figures. And some of these figures, they're actually on the UK government site, so you can, have a look for yourselves and find out for more information. But you can see it's pretty dismal. When I started in 1998, it was like 3%. I mean, now we're looking at 6%. So do have a look, and you'll see the reasons for why it's important that I say these things and I stand before you. The gender disparity among inventors grows even starker when you take account that most female inventorship takes the form of a lone female on a male-dominated team. And here we go, more facts and figures. So for those people who are skeptical about inventors, and especially when I mentioned earlier that when you look at an engineer, you look at your end goal, and you look at the end goal of an inventor as well, it's not that dissimilar. But look at the percentages here. They're not great. So this is quite serious. And to think Russia has the highest share of women inventors, we have France, Taiwan, China, Canada, USA, UK, 9%. But at the same time, when you go onto the UK government site, it sounds very exciting. Female inventorship in the UK has increased from 8% in 1998 to 11% in 2017. Other countries are, however, well ahead. So it's not really that bad from the way they've kind of put the report together. But I'm still frustrated with these kind of figures. So why are there so few women in the world of inventing? Researchers attribute the gap to a lack of women working in science, technology, engineering, and maths, STEM. The same old story. I think we know that, but we need to say it over and over again for people to really see and understand the importance of STEM. If we want to see more women filing patents, then we need to see more women taking up STEM subjects at university and going on to careers in research, according to Penny Gilbert, and quite a number of others who have taken their time to research into this area. Stereotypes around women's educational and career choices still need tackling. By encouraging women to choose STEM areas, introducing mentoring schemes and celebrating female role models, more collaboration between women's groups tackling this is needed. I don't think we can stay in our corner and say, well, we're women in this and women in that. Inventions right across every sector. So I think there's a need for us to collaborate. And when I say we, I mean global women to collaborate with organizations like yourselves and take these forward. So we need to address the disparity and inclusivity. And that's where I start to introduce our organization. Our focus is on women in business, in the workplace, in education that are inventive, innovative, and exceptionally creative. We work in collaboration with educational institutions, government departments, leading industry experts, voluntary organizations, and I'll just say practically everyone and every individual organization. We push boundaries, and it's not easy. Not when you're talking about inventions. You know, I had the opportunity to speak at TED Global in Los Angeles. And I was amazed with the amount of people that came to speak to me afterwards about their experience by actually standing up and saying, I'm an inventor. It just goes to show that there is still an issue for us to really start to look at how we can celebrate and appreciate and actually bring inventions and inventors as positive role models. Dedicated to women innovators and inventors, that's what we do. We've designed a network as one of the intellectual properties industry's most prestigious awards. I would say this is one of the things that we try to push. It's a one-stop shop to eliminate challenges women face in bringing commercially viable products to market. It's a vehicle that influences the development of creative ideas, products, and services for social and economic growth. Investing in collaboration and partnership. Despite all odds, let's create opportunities together. Why reinvent the wheel? We need to benchmark our skills, retrain, reskill, and retool. Let's take advantage of current and emerging opportunities and stimulate wider inclusiveness and the exchange of knowledge. Global Wind is actively pursuing progress every time. It's a global network. Yes, it started in the UK, but we've had to go out because some countries are doing it better than others. And some countries are taking more notice than others. So the knowledge exchange platform that we've created is one that also takes into consideration a summit and an awards that brings all of us together. intellectual property, we can't get away from it. It's a vital component of innovation. So you mentioned earlier when you were introducing me that I've just become a director of IPAN, but it's one of the reasons for why I felt it was important to take part and join and be part of this network, because we need to look more at intellectual property and have a much more understanding of what that could do for a lot of the products that are coming out. And so within the Global Win Awards, we did include the IPAN Gold Awards so that we can specifically look at those who have intellectual property rights. Now, without any investment, without any funds, without any finance to take a lot of these wonderful ideas forward, a lot don't get done. So we had to start looking at investment opportunities. And it's one of the reasons for why I accepted to collaborate and speak at the World Business Angels Forum in Turkey, which was about last month, I believe. So kudos to Women's Engineering Society for addressing this issue, because I know that you've started to really look into women inventors. And some of their proactive response that I've found, that I've seen, is putting spotlight on key trailblazers. I saw the publication by Emily Teasdale on patents, the benefits and pitfalls, the fact that she was able to speak at one of your events. Women Inventors, Catherine Markle's book on Mother of Invention, How Good Ideas Get Ignored. And of course, the awards that took place where I became the head judge, looking at women in engineering that are inventors and innovators. Paying it forward. I felt that there's a need to inspire, because when I actually read a lot of the applications that were put forward, the nominations that were put forward, I saw quite a number of women who were doing great things. They were inspiring compassion, changing existing circumstances for the best, introducing new people who might enrich others, providing knowledge exchange that really do matter. I'm so pleased that I get the opportunity to speak here and to learn more about Dame Caroline Haslett, because when I looked at what she was doing, because I had to quickly go and do my own little bit of research, I thought this is a woman that was paying it forward. The message that I put across all the time. She's a great role model and an early champion of women's rights. Of course, you've heard that. Making life easier for women. Effective networker. I can't, stress how important it is to network, because by doing so, you're able to meet others, but also help others. So she was an effective networker and used invitations to lunch as a starting point for many useful working relationships. She's instrumental in opening the world of engineering to women, you've heard that, and advocated the use of electrical power, which you've heard before, so I'm not going to go over it again. But of course, you can see that she put a lot into that. And these are the kind of role models that I think that we should try and aspire to become, if you're not already doing that. As head judge, I read a lot about women doing great things, women engineers. Two women that came to my mind that I thought that, yeah, they're paying it forward. Ruth Amos, inventor of Stair Steady and co-founder of the Kids Inventor Stuff on the YouTube channel. I watched what she was doing, and I watched how she was trying to inspire young people over and over again. And Nigel Young, the president of the European Young Engineers, I think about 50,000 young people that she's inspiring around the world, and of course, Europe in particular. So we've also tried to do our bit in paying it forward by impacting 20,000 ingenious-minded STEM women, and that's going to start in this particular year, right up until 2030. That's our goal. Our mission is to help close the digital divide, position women in becoming more competitive in the digital and STEM space, speed up economic integration, embrace new and progressive digital technology. And I don't know whether you know, but this NFT thing is really growing so big that I can't even keep up with it. And I can't explain most of it, but I do know that it's something that we want to try and start to get our head around. human capital and the sustainable management of natural resources. But we can't do all of this on our own. And that's why I put that quote. No one can do everything, but everyone can do something. I think I put that there before. I'm not sure whether this is a repeat, but yeah, duplicate. So finally, I just wanted to say to you that, yes, we started in the UK. We did a number of events and award ceremonies in London. We moved from London to Wales and to Scotland. And then we noticed that quite a number of women were coming from various parts of the world and joining us here in Britain and asking, when are you going to come to our country? When are you going to come and put the spotlight on women who are really struggling to get those brilliant ideas out? And we were like, well, we're struggling to even sort ourselves out in the UK. And then the invitations started coming. And I'm pleased to say that over the years, we've been able to take this UK initiative to some wonderful countries: Belgium, Finland, Germany, Estonia, Ghana, Iceland, Italy, Mexico, Nigeria, Sweden, South Africa, Senegal, Singapore, and of course, we started here in the United Kingdom. So I'm inviting you, please join us at our next event, which is in Iceland in September, and bring your innovative ideas and come and join us and inspire and pay forward to those women who are bringing new ideas for a better quality of life for each and every one of us. Thank you very much.
I've been told to press the red button. Yes, hello. Can you hear me through this microphone? Excellent. Thank you so much. I can hear myself now. Thank you so much, Paula. And it's just a shame that your conference coincides with my honeymoon. Because I'm actually getting married twice. Once on the 7th of February, less than 3 weeks, a small civil celebration. And then we're having a big humanist wedding on the 2nd of September, and we're going to Madeira. So I'm so sorry not to attend, but do try and get to this conference in Reykjavik if you can. So does anyone have any questions for Dr. Olabisi? Yes. If you could tell us your name.
Hi, good evening. My name is Abisala Ojani. Wonderful presentation. I think it's very inspirational. I'm a founder for a network called BWENG, Black Women in Engineering, because of the need for a network like that. And, you know, it's very much inspired by Wes as well. And we're like 2 years old. But finding out that you started your organization in 1998, it's amazing and mind-blowing that you're still going on. And I just want to know, how have you managed to keep it going? And what's kept you motivated all this time?
Right. Thank you very much. I wish I knew the answer. But I have to say that I'm surrounded with some absolutely brilliant women and men. And I should have mentioned that we do have a lot of male champions that support us as well. And the fact that you can see progress, you can see light at the end of the tunnel. Sometimes people feel that an inventor is going to end up becoming a business person, is going to end up becoming a huge, but sometimes that's not what they're after. They're not necessarily wanting to get things to market, but they just want to see something that's going to make life better. And I have to say that a lot of the women that we have worked with stay on, and they join the network and they support others. And that's where the paying forward actually matters. So I don't know whether that actually answers your question, but perseverance. And, you know, sometimes we sit there and we say 1998, we knew there were so many women organizations there at that time, but we're still standing. Thank you.
Thank you. Any other questions? There's one at the back there.
Hi, I'm Natasha Stephen. I'm the Director of Science and Engagement here at the Geological Society, and half of our fellowship are very much engineers in the geodisciplines. So it's really fantastic to be here and to meet you. I had a question after seeing some of the data you presented about the number of inventors who go forward and put patents in that are accepted, who are women. And I just wondered, do you think there's a correlation between women in STEM disciplines in, for example, an academic environment where people are encouraged to apply for patents, but the institutions then own the intellectual property behind that patent? So when women leave the institution, and we see a lot of women, unfortunately, through the leaky pipeline and not being supported enough to stay in those institutions, do you think that's a problem with the IP belonging to the institution rather than the individual?
Right, thank you. It is rather complex because you're talking about patents and ownership. Some organizations it depends on the rules and policies within the organizations. I'm not so sure that's the issue, because sometimes they may not necessarily own it, but they will certainly have the people who have actually come up with the idea. The names are usually there. I feel that it's only just recently that you start to see women actually taking real ownership and going in on their own as lone inventors. Within organizations, it's a bit more trickier because you work most of the time as part of a team and not necessarily on your own. It's easier when you're a lone inventor, but as part of a team, but even all the same, you'll see the names. And I think the data actually showed those who were part of a team as well. So yes, the figures are still down, and we need to do a bit more to put it up.
We have a similar problem with engineering in that only 16.5% of all engineers are women, but this is an increase in 2010. Where's this part of this may have been to improve it? We have time for one more question. Okay.
Hello, hi. My name is Huda Asad. I'm from Accenture. I just wanted to say, first of all, amazing. I'm like overwhelmed and excited to hear about the work that you're doing, because when you asked the question, if you're an inventor, I thought I didn't put my hand up because I never considered myself as an inventor. But when I was on a construction site, I developed quite a technical thing of installing something on in steel and concrete that then was patented by my employer. They owned the intellectual property rights because it was in my contract. I was paid £1 that was sellotaped on an envelope and posted to me. And my name never made it onto anything because the program director got his name on the patent, but it was the company's. And actually, I think if I had the awareness, if I had known about your organization, it might have encouraged me to think, to sort of maybe be a bit more demanding that I had my name on it or something like that. Ultimately, it didn't matter. I don't think they made billions out of it, but but there is a kudos thing. So I wanted just to say thank you very much for the work you're doing and the awareness you're raising. I think it's awesome.
Thank you. Thank you very much. We have so many stories, so many case studies of women with great ideas that, and some of those products are on the shelves, but because of the lack of awareness and the confidence to actually take it forward, they walk, and it's hard. That's your baby. You're walking past every day. You're watching it, and you know that you could have, had something from that. And as I mentioned earlier on, that community development is an area that I specialize in. When you look into the communities and you see that it is true, necessity is the mother of invention. When it's hard, you will come up with those ideas to solve those problems in the most affordable way that you can. And so we have a lot of mothers, a lot of people working in the hospitals, working in care opportunity places, industries, coming up with medical opportunities for people, new creations, and even areas where it isn't really high technology, but highly viable areas. So yeah, well, thank you for that. Okay. Right.
Thank you again, Dr. Wow, we were so lucky to have Bola as as our head judge for the top 50 women in engineering, and I'm so delighted she's been able to share her experiences today. So we now turn to the first of our awards this evening. This is the Men as Allies Award, to celebrate a male engineer or professional man working within the engineering, technical and applied science sectors, who has gone above and beyond the call of duty to support his female colleagues and to address the gender imbalance within engineering and applied sciences in general. And we have 3 finalists this evening: Stephen Gill, who from the Secretariat of World Refrigeration Day, Andrew Nicholson, Director of the Fire Surgery, and Elliot Taylor, Silicon Architecture Engineer at Intel Corporation. Sadly, Elliot has COVID and can't be with us this evening, but we do hope he recovers soon. And the winner, after 4 times of being nominated, finally, Stephen Gill, Secretariat of World Refrigeration Day. I'm going to read out a citation about Stephen, and then I'd like to ask Adriana Vargas Colwell, one of the WES trustees and the head judge of this award, to come and present this award to him. This comes directly from his nomination. I have known a lot of men who are allies of women in engineering, but nobody comes close to the level of dedication and going above and beyond that I have experienced with Stephen. Not only was that said by Alex Knight of Stimazing, but it was also said by countless other women engineers. Stephen Gill has been a Men as Allies runner-up in 2019, 2020, and 2021. And in fact, I happened to know when I last saw him just before Christmas at a dinner that he'd won, and I had to pretend that we were going to keep him on the shortlist forever just to annoy him. However, each nomination of these has stood on its own merit, each being different from the previous year, which is remarkable in itself. And there are far too many examples of Steve's ally work to list, but here are just a few that stand out from this year alone. And to be honest, I've actually only taken 5 because there were many more in your nomination. So it's amazing. Since January 2021, Stephen has personally paid for and encouraged 60 women engineers from his network onto this amazing programme. April 22, Stephen launched in partnership with the UN, the International Network for Women in Cooling. This has been described by Jin Curling, head of UNEP's Ozone Action, as a landmark initiative, and this network is already 2,000 people strong. In June 2022, Stephen donated a prize fund of $500 to encourage women engineers across Africa to make videos of themselves working that could be used to encourage other women to enter engineering. The few engineering career films available at the time were in English, featuring mostly white men, and now 14 videos of approximately 19 minutes each were submitted from 8 African countries in several languages. Not only that, Stephen has worked with neurodiversity and ethnic minorities, successfully supporting a further 3 Black and minority ethnic women with dyslexia in this last year to become chartered engineers. And for INWED 2022, Stephen produced a collage featuring 600 women from the cooling industry, raising their viability. All of this is unpaid and voluntary, and in addition to his day job as a consulting engineer. Stephen strongly believes in making women engineers more visible, and as a true ally, he is less visible than the women engineers and students he encourages, a truly worthy winner of the Men as Allies Award. Adriana. You can't be nominated anymore either. But I'm sure that Steve will continue to, encourage more women engineers. We now come to the Amy Johnson Inspiration Award, which has been created by the Women's Engineering Society to honour an individual not currently working as an engineer or within the applied sciences, who has made a truly remarkable achievement in furthering diversity within engineering and applied sciences by inspiring more women to enter and or remain in these professions. And our 2 finalists are Natasha Kelly Programme Manager at Intel Corporation, and Jackie Sandbach, Head of Technology at Lancaster Girls Grammar School. And I'm delighted to announce that the winner is Natasha Kelly, Programme Manager at Intel Corporation. And again, I shall read this citation and then call on Vince Pizzoni, one of our trustees, to present the award. Unfortunately, Paul Cliff, our head judge, is not able to be here this evening. Chair of UK Women at Intel, which the network is called Win UK, and the Sales and Marketing Group SMG Win Spotlight Role Model, Natasha Kelly is and has been a driving force for several years, raising profiles of women within the company and prompting executive action to rectify the poor numbers in leadership and engineering roles. She encourages conversations on topics of interest and concern to women through workshops, drop-ins, podcasts and newsletters, whilst promoting the need for more information and opportunities to be included in the company information packs for prospective employees. Tasha brings energy, focus and momentum as UK Win Chair. Through inclusion, empowerment and delegation, Win UK tripled its active membership in the last year. Their interns help relevancy with current topics, resulting in an influential employee resource group respected across its peers. Seeing a gap in Intel's technical stream progression, Tasha has coached to establish an active technical win stream, winning the Cross-Site Award for Technical Development. The group's events, podcasts and learning opportunities extend to all. With business discipline and clear objectives and success measurement criteria agreed, the initiatives pulled in the broader community and allies with insights and successes shared across all WIN chapters. In 2021, the team ran 21 events with an average attendance of 40, achieving an average satisfaction percentage of 94%. Tasha has been a great advocate for diversity, ensuring representation at all levels, challenging leaders and sponsors to step up, and she initiated and led the fireside chat with Intel CEO Pat Gelsinger on WIN, gaining over 1,200 views. What Tasha has done for women engineers at Intel is the gold standard for women engineers across the UK, and she is a well-deserved winner of the Amy Johnson Inspiration Award. Natasha is also a colleague of Elliot Taylor, who was a finalist in the Men as Allies Award at Intel Corporation. And we're very impressed that Intel actively demonstrates its promotion of women engineers by supporting men and non-engineers in their diversity work. Congratulations, Natasha. We now turn to the Karen Memorial Award, presented in recognition of the best newly chartered woman engineer. Now in its 23rd year, this prestigious title recognises the candidate's excellence and the potential in the practice of engineering. It highlights the importance of having chartered status, as well as offering recognition to contributions made by the candidate to the promotion of the engineering profession. And past winners have gone on to great things, including the 2008 winner, Emily Spearman, who is now a WES trustee, 2009 winner, Katie Deacon, profiled as ingenious by the UK Research Council and E&T magazine, and Professor Molly Stevens, now a Fellow of the Royal Society, trustee of the National Gallery, and winner of the Institute of Physics Rosalind Franklin Medal, among other awards. We anticipate that this evening's winner will also continue to make her mark in engineering. Dr. Karen Burt was a tireless campaigner for the recruitment and retention of women in science and engineering. From her own experience and her extensive research, she was regarded as an expert in the management of career breaks and women returners to engineering at a time when this wasn't something that was commonly thought of. From business acquisition manager at BAE to establishing the Centre for Advanced Instrumentation Systems within the University College London, her career was sadly and abruptly ended by a devastating stroke. And we are delighted that the prize money of £1,000 has been donated by Cyril Hilson, who is Karen Burt's father and who is always here at this award. Thank you so much, Cyril. So this year's nominees: from the Royal Aeronautical Society, Laura Cruz Garcia; From the Institution of Fire Engineers, Nayand Esteve. From the Institution of Engineering and Technology, Dr. Stephanie Liggins. From the IOM3, Dr. Amy Nomiots-Nom. From the Institution of Chemical Engineers, Kalita Patel. From the Institute of Physics, Dr. Emma Walton. From the Institution of Civil Engineers, Carmen Young. And from the Institute of Mechanical Engineers, Terry Zrodzewski. It is the usual practice for the head judge of the Karen Burt Memorial Award to present the winning citation. However, as mentioned earlier, Dr. Critchley is unable to be here today, so I will read the citations, and I would like Dr. Bola Olubisi to make the presentation to the winner. So this year we have identified two women as highly commended, Dr. Stephanie Liggins and Dr. Amy Nomiots-Nom. Dr. Stephanie Liggins has a PhD in physics and was nominated by the Institution of Engineering and Technology for her engineering work and researching novel processes for the synthesis of diamond for technological applications. Dr. Liggins was a very close runner-up for the award and demonstrated excellent engineering, innovation and academic application in her nomination. Her engineering work includes the development of a diamond tweeter dome, which is responsible for generating the upper frequencies in sound replication from a few kilohertz to 20 kilohertz, for example, orchestra strings and vocals. I sound so knowledgeable, don't I? Somebody else wrote this. Dr. Liggins led the development from concept to production, from pre-synthesis material processing, synthesis recipe development, reactor engineering, to post-synthesis quality control and quality assurance. Dr. Liggins has written a number of articles for Physics World, Materials Today, and Gems and Jewellery, sharing her story as a female scientist and engineer, the challenges and opportunities it has presented, and reflecting on why women are so underrepresented in STEM subjects. As a leader in Girl Guiding UK and with the Institute of Physics, Dr. Liggins led mad science activities at festivals and international jamborees, making science and engineering accessible to young people through practical hands-on demonstrations and play. Dr. Liggins embodies the wonderful achievements of engineering design and application, coupled with passion for her subject, which she shares with others to build diversity in the engineers of the future, and another wonderful inspiration for women in engineering. Thank you for being an excellent runner-up. Dr. Amy Nomiots-Nom has a PhD in material science from Imperial College London and was nominated by the Institute of Materials, Minerals and Mining, known as IOM3. She has made a significant contribution to engineering through her research on the development and characterization of bioactive glass scaffolds, which led to the first material to form a stable chemical bond with human bone. And speaking as somebody who has a very badly broken leg, this is going to be amazing. Dr. Nom's work has been very well received by the glass community, leading to many publications and conference presentations, as well as being elected onto the Bioactive Glass Technical Committee for the International Commission of Glass as its youngest ever elected member. Dr. Nomiots-Nom also sits on the advisory board for the Royal Academy of Engineering's Explore programme and was selected as one of the Foundation for Science and Technology Future Leaders for 2022. In her current role, she's in the process of developing a network of deep tech investors with backgrounds in engineering and the physical sciences, and is looking to create a community which actively supports underrepresented entrepreneurs, including female engineers, who are driving technology from the university ecosystem. Dr. Nomiots-Nom shows how being a chartered engineer with her career in research and investment, coupled with a passion for working with underrepresented groups, is making a wonderful difference for other women in the engineering field. And thank you for being another excellent runner-up. And I'm delighted to announce that the winner of the Karen Burt Memorial Award 2022 is Dr. Emma Walton, as nominated by the Institute of Physics. Dr. Emma Walton has a PhD in physics in the optoelectronics of liquid crystals and was nominated for this award by the Institute of Physics. Dr. Walton's engineering work in the development of miniaturized sample preparation product for point-of-care diagnostics replaces the need for length analysis at a laboratory with an on-the-desk instrument which is able to analyze patient blood samples in real time. Dr. Walton had to take a general project aim and create the targets and exact specifications to make the product work and to be able to produce it at scale. This work combined her skills in mechanical and optical systems design and her ability to work with experts from across the fields of biochemistry, electronics, software, and data science to miniaturize the functions of an entire medical laboratory in the form of a lab on the chip. It was this groundbreaking work that captured the judge's attention, as it is cross-generational in its application and will continue to make a difference for future generations to come. Dr. Walton's strong contribution to engineering, coupled with a clear passion for her subject, make her an inspiration for all other female engineers to make a real difference in the world with the work they do. And for this reason, we are delighted to award the Karen Burt Memorial Award to Dr. Emma Walton, and she will be giving us a presentation as well. Bola, if you'd like to come forward to make the presentation. So the prize winner gets to give a presentation on her chartered engineering project, which we will hear in just a moment, but also just to remind her, there is a prize of £1,000 from the Women's Engineering Society. It's kindly donated by Professor Hilson, and we will be getting that to you this week. Thank you. There you go. So, thank you.
Well, good evening, everyone. So before I begin my presentation, I'd actually like to ask a favour. So for those of you in the audience that have an orange sticker, please could you stand up for me just for a moment? Okay, so there are 3 of you standing up in an audience of about 80 to 100. And this really reminds me of my physics degree at university. I was one of 3 students in a class of about 80 to 100. It made for a really daunting start. So it's been a passion of mine throughout my entire career to try to help inspire the next generation of female engineers. Thank you. So as you now know, my name is Emma Walton, and I'd like to say an enormous thank you to everyone involved in the Karen Burt Memorial Award process. I was incredibly surprised to be nominated for the award and even more surprised to find out that I'd won. I'm really honoured and delighted to be standing here this evening. So I've been asked to say something about my career. So I thought I'd tell you something about how I got into engineering in the first place, then my career in industry. And I'd like to tell you something about what I like to do outside of work to try to help inspire the next generation of female engineers. So starting out, it was a pretty dodgy start, to be fair. So when I was about 7 years old, I decided to undertake my first big experiment. For some reason, that was to reverse engineer my big sister's favourite alarm clock. So I had 2 lessons that day. But the first was that disassembling something is much easier than reassembling it. And it's a really good idea to keep track of your parts. The second lesson was nothing to do with engineering, I'm sure you're aware. In the years that followed, I actually liked to sneak into my dad's garage and borrow his tools. I was very fond of his Stanley knife for making bows and arrows, and his saws and chisels for making shelves for my bedroom. Another learning lesson was about tool safety and how the local accident and emergency department worked. At the age of 14, my career nearly came to an abrupt end. So I needed to choose my GCSE options, and being more comfortable with a saw than a spatula, I thought I'd take design technology. And I was told categorically no, girls were not allowed. It was for boys only. And I was absolutely outraged. And I think it even activated a stubborn gene within me. And I'm pleased to say that I became the first girl at my local comprehensive school to study the subject. But perhaps now looking back, what was even nicer was that in the years that followed, there was a real growth in the number of girls studying the subject. So from school, I went to university, to the University of Exeter, where I studied for a degree in physics. And I really liked the optics topics within my degree. And so understanding lens design and things like why is the sky blue and how a rainbow is formed. So I decided to further educate myself, and I studied for a master's in optics. Okay, so moving on to my career. So really it was my optics skills that got me my first job at Sharp Laboratories of Europe, pictured here, whoopsies, pictured here. And Sharp was a really big Japanese company specializing in displays. And I was very lucky because I joined the displays industry just as it was taking off. This really pains me to say, but for those of you that are old enough, if you look back to the mid-1990s, which is when I started work, displays were actually still relatively basic. So we had simple black and white displays with alphanumeric displays on things like calculators and watches, and these were mass produced. But it was really the next decade that saw a big boom in the market. Mobile phones became a big thing, as did big hang-on-the-wall TVs. And it was my role in all of this to use my optics skills to help develop these new displays. During this time, I also designed and developed optics to go in the next generation of projection displays so that you could project an image like this. And I even contributed some development towards the optics inside the 3D Nintendo, which some of you youngsters may even remember. So I had a particularly proud moment when I worked on a display that was mass produced by Sharp, and it was called Veil View. And this display has two modes. It has a normal mode in which you can look at the display and see it from all angles. And then at a touch of a button, it would switch into a private mode. And in this mode, the user could see the display head on, but somebody off to the side would see an entirely different image. And this was particularly attractive for people, for example, commuting on a train. So maybe you want to do your bank work and you don't want some geezer over the side having a look and seeing what you're doing. And this made a big splash, particularly in Japan, where you get a lot of commuting. And it was published, well, reported in newspapers around the world. And I was really lucky because I got invited to the press release over in Japan and won an award for my work. So I developed technically on a hugely, but I also developed on a personal level. So I got to travel to Japan on numerous occasions and experience an entirely different culture, which is just amazing. I also had to travel there independently, which, whilst terrifying at the time, was really good for me. During this time, I also learned to write patents to protect all our ideas. And in my spare time, in my evenings, I chose to write up some of my work to gain a PhD. So I worked on displays for many years and I really enjoyed it. It was very challenging, very rewarding, but I decided I fancied a new challenge. And so I transitioned into a new and emerging field called Lab on a Chip. So I joined a fledgling team. I think there were 5 of us at the time, aiming to develop a lab on chip device. So you may be wondering, what's a lab on chip device? Well, the concept is to take an entire biochemical laboratory and shrink it down onto a really small device, just the size of a credit card. Why might you want to do that? There are numerous applications, but perhaps my favorite is in the healthcare area. So I'd like you to imagine a scenario, you're not feeling very well and you go off to the GP and they decide to run some diagnostic tests. They may take a sample of blood or urine from you. And today, that sample would be sent off to a laboratory somewhere for analysis, and it would sit in a queue along with everybody else's samples until it was time to be processed. And this might incur a delay to your treatment. But if instead this GP had access to a lab on chip device, he or she could input that same sample of blood or urine into the device and get an instant diagnosis at the point of care, leading to instant treatment. So I think that's a pretty nice concept. So what about making it happen? Well, this really appeals to me as well, because you need a really versatile team. So you need biochemists for developing the assays to go on the lab on chip device. And then you need a whole team of different engineers for developing the lab on chip device and the instrument for running it. So you need electrical engineers and software engineers. And then you also need mechanical engineers, optical engineers, and fluidic engineers, which is where my experience comes in. So what did we all develop at Sharp Life Science? Well, we developed a platform called the AccuDrop. And the picture on the left here shows the AccuDrop device, which is designed to engage in the instrument on the right-hand side. And in use, the user would just take a stamp like this, and they would load fluid in through these ports on the side of the device to create these little reservoirs. And what's nice then is that user can go and sit down, have a cup of tea, because it's time for the software to take over. And so the software is programmed to take these, sorry, I'm shaking, take these reservoirs of fluid and dispense these baby droplets of fluid here, which could, for example, be the blood or urine or other buffer that's required. And then the software moves these droplets around the lab-on-chip device as required. It can mix them together, merge them, split them apart, whatever's needed. And then this instrument here contains optics, magnets, heaters, things that you routinely find in a biochemistry department to complete the assay. So I worked at Sharp Life Science for several years before I transitioned to the company where I work today, which is Oxford Nanopore Technologies, which is shown here. And this is a company that specializes in DNA and RNA sequencing. So at Oxford Nanopore, we've developed a range of devices, from small portable ones for use in the field, like the one shown in the photograph, to much bigger benchtop devices for use in a laboratory for high throughput. And there are a huge range of applications. But I'm working on an instrument called Voltrax. And this photograph here shows some scientists in the Gobi Desert using Voltrax here. And the point of it is that these scientists, they can't take an entire laboratory to the Gobi Desert, but they can take a lab-on-chip device, which is exactly what Voltrax is. And in this example, these scientists were taking samples from a bat and then preparing them for DNA sequencing using Voltrax to look for coronavirus. So what's my role in Voltrax? So I thought it might be easier to show you a device. So this is the instrument. It's portable. It can sit on my hand, and it connects via a USB cable into a computer. And it then has optics and magnets and heaters, things that are routinely found in a laboratory. And then it has a lab-on-chip device, which we sometimes refer to as a cartridge, which just clips on top of the instrument like this. And then in use, the user puts fluid into the lab-on-chip device. I'm sure you can appreciate there's a lot to do in the design and making of this sort of thing. And I've just tried to pull out two things that I've been working on. So one of them is the next generation lab-on-chip device. And that's so that we can add functionality so that new assays can be developed and new markets can be explored. And then the other thing is the optics. So inside the instrument are some optics, and I'm trying to develop those so that, again, we can develop new assays and explore new markets. But what's kind of interesting about this optics is it's actually really, really complicated. You have like a blue LED inside this instrument, and it's designed to illuminate a sample inside your cartridge. And then that sample fluoresces and creates green light, which you then have to capture without capturing the blue light. So it's all fairly complex. And I'm sure you can imagine there's not much space inside there for optics, so everything's very tiny. So my job is really varied and really challenging, which is why I find it so rewarding and why I enjoy it so much. So I said that I'd finish by telling you some of the things I like to do outside of work to help inspire the next generation of female engineers. Well, for me, this starts at home. So I've got two lovely children, a boy and a girl, and I've been very keen to develop their science skills. We've had loads of fun over the years doing all sorts of things, and here's just a handful of photos. So, oopsies. So this is where we're hatching butterflies from caterpillars. Here we're making bath bombs, which we made in the shape of R2-D2 and Princess someone. Here we're making cornflour mixtures, which some of you may know as non-Newtonian fluids, which behave in really weird ways. Dance on a disassembled loudspeaker. Yes, I did reassemble a loudspeaker. And here we were making a bicycle pump powered rocket, which we fine-tuned so much, it really needed safety goggles. But I've also been keen to encourage the science skills of other children, because I think little children is where you capture their imagination and start bringing them through into STEM subjects. So I volunteered many, many times at my local primary school, trying to run inspirational science workshops. I've been really keen to capture the attention of girls in particular. So here we made electronic butterflies with light up noses to explore electric circuits. I've done workshops on magnets where we've made magnetic games and bookmarks, and this is an example. I took magnetic fluid into school so they could wow with bringing magnets up close, and they form these spiky patterns. Here we learned to balance patterns of nail varnish on top of water, and then we got pieces of acrylic and dipped them through to transfer the pattern onto acrylic to make pretty pendants for the girls and key rings for the boys. And here we learned about different mixtures for making really big bubbles. And I challenged the children to blow bubbles within bubbles, which really isn't very easy, and also make bubbles big enough to stand inside, which is quite cool. And what was really nice with this is I've actually had children knock on the door and ask if they can come and play science. So that's nice. I've also been keen to help teenagers. So any teenagers that want help in GCSE or A-levels, STEM subjects, I invite them in and help them out. And I really enjoyed helping the girls, because every single one has turned up saying, I can't do maths or I can't do physics, which is wrong. It just needs encouragement and patience, and they get it. Whilst at Sharp Laboratories of Europe, I worked alongside the Small Peace Trust educational charity, delivering multiple talks to female students and boys actually, trying to give them an idea of what a career in physics might be like. And I really hope that I've educated and inspired some of them. And then finally, of course, I like to try to help promote science roles for those females that have already decided to undertake a career in physics or engineering. So I'm a member of the Institute of Physics, and I've written an article for Physics World about career options for physicists. And I've taken part in adverts and articles and videos to try to promote science roles. So finally, I was really lucky that I had somebody to inspire and support me throughout my career, and that was my dad. And it was my dad that realized my passion and my ability in physics. And he told me, why don't you stand up and dare to be different? And wouldn't it be nice if the coming years, if many more females were prepared to stand up and dare to be different, so in the end, we're not different at all. Thank you for listening.
Thank you so much, Emma. And I think she's really demonstrated she's an absolute worthy winner of the Karen Burt Memorial Award. We just have time for a couple of questions. So does anyone have a quick question? And then we can go to drinks and you can network with Emma there. Yes, here. Yeah, I want to play science too, actually. And we work with the Small Peace Trust as part of the Engage Alliance with McLaren, and I know Kevin Stenson.
Oh yeah, I know him very well.
Yeah, he's a brilliant, inspiring man himself, and he has daughters he's trying to get involved in science as well. So I'm so pleased you're working with them. Any other questions? Yes, at the back here.
Thank you for this inspirational evening. I'm a DT teacher and STEM head of DT and STEM in a secondary school. I also work in a primary school as a governor. And thank you so much for this inspirational evening. It's good to know that there are people in here who want to lead and support. And I think that I'm here with a colleague who actually invited me, Rose Russell. And there's one thing we've started to say to our young people, that they can't be what they can't see. And so it's so good to see people who are working in these fields to show. And my question is, getting more people into schools. I know it's challenging because of the hurdles that we have to get through, but there are schools like ours that are willing to engage, and they are primary schools. And indeed, you need to start by nurturing them. So thank you for the work you're doing with Small Piece. And it's also to ask for mentoring. I think that our young people, if they find that they can speak to people, those barriers are broken and they shine, because they then get to see the people that they want to be. And there was a quote that I got from Amma. She won the Young Women Engineering. She says that sometimes if you can't see what you want to be, just become. And I believe that you are the inspiration. So please do come along and please continue your work. Thanks.
Thank you very much. And I just want to say thank you very much to my team, including Candy Colburn, our events manager, who's here to help put this together, the Royal Geological Society and their staff for helping us, both catering and for AV, and to our speakers, Anne Locker, Dr. Bola Olabisi, and Dr. Emma Walton. And many thanks as well to Professor Hilson for providing the funds for this award. And I'm delighted that every year, and this is 23 years now, and the 4th time I've been involved, that we get to see so many brilliant and inspiring people, and particularly women chartered engineers. I hope you have a lovely evening and good, safe journeys back home, and we'll now have some drinks in the library. Thank you.